Welcome to the class, dear students. In today's lecture, I am going to explain the vector algebraic operations. What are the operations here? So the first one is the vector addition. How to add two vectors? That is vector addition. And you have the vector subtraction. How to subtract two vectors? These are the topics. And what is the vector multiplication by a scalar? That is the scalar multiplication of a vector. All this we are going to do. So how to do all that? Let us see that there is a vector. Let us consider this vector, let us say. Now this is the vector represented by 2, 3. I hope you know, all of you. 2, 3 is the vector, and let us call this vector, this is 2 units towards the x-axis, 3 units towards the y-axis. So I call this vector as u bar. Let us say that this is u bar. And I wanted to see one more vector. Let us have 3, 4, 1. 4, 1 is another vector. Let us call this vector as this one. Okay. And let us call this vector as v. Now, we wanted to see that the vector addition of these two vectors. That means mu u bar plus v bar. So we wanted to see that this is the addition of the vectors. Now we are writing this addition of the vectors. Let us first write down that one. So what is u bar plus v bar means? Just add the x coordinate 2 and x coordinate 4. 2 plus 4 is 6. So where is on the x coordinate? On the x axis, let us see that this is 5 and this is 6. Now at the on the x-axis look at 6, and what is the y coordinate here? 3. Y coordinate is here 4. So 6, 4 is somewhere here. This is the vector given by 6, 4. And so this vector is denoted by u bar plus v bar. So how is this? This is the vector u bar plus v bar. This is the vector 6, 4. U bar is this, v bar is this, u plus v bar is the vector given by 6, 4 like this. This is what the vector addition of any two vectors. Now let us see the vector the subtraction. That means what? The difference between the two vectors. Let us see what is 4 minus 2. 4 minus 2 is somewhere here, and 1 minus 3 is minus 2. So it will be somewhere here. So this vector is given by 2, minus 2. Now we denote this vector as, let us have this one as u bar minus v bar. U bar minus v bar is, this vector gives you u bar minus v bar. This vector gives you u bar plus v bar. So this is what the way of representing the two vectors. Now what do you mean by the vector addition? By the general formula is, suppose if you say u bar is x1, y1 and v bar is x2, y2, let us say, then u bar plus v bar is given by x coordinates x1 plus x2, y1 plus y2. This is what the notation for u bar plus v bar. In the similar way, you will see u bar minus v bar is given by x1, y1 minus x2, y2, let us say. Then this is given by x1 minus x2, x1 minus x2, y1 minus y2. This is u minus v. So this is what the vector addition and vector subtraction, that means u minus v. So let us now have the scalar multiple of a vector. So that means what? Let us say the scalar multiple of a vector. What do you mean by the scalar multiple of a vector? That means you multiply a vector with some scalar u, k. So that means k times of your vector is what? U is given by x1 comma y1, correct? So it is k times of x1 comma k times of y1. This is another operation. For example, you have u bar is given by, let us say, 2 comma 4. And what is the scalar k is given by, let us say, 5. Then what is the scalar k times of u bar is given by, this 5 is multiplied by 2, 10. 5 is multiplied by 4 is 20. So this can be written as 10 comma 20. So a scalar multiple of a vector we write like this. And what is the representation of this? This is 10i plus 20j in the vector representation. Okay, so these are the vector operators of the given vector. Now let us say there is a space vector that is meant by, what do you mean by the space vector? A three-dimensional vector is given. Suppose let us say your vector u bar is given by u1i plus u2j plus u3k. That's a three-dimensional vector is there, suppose. Then how to find out another vector v bar is there, suppose v1i plus v2j plus v3k. Then what is the sum of the vectors u bar plus v bar is nothing but u1 plus v1 comma u2 plus v2 comma u3 plus v3. This also can be written as, this is nothing but when you are writing in the three-dimensional as a triplet, then u1 plus v1 I plus u2 plus v2 j plus u3 plus v3 k. This is your u plus v. Now what is u minus v is given by u1 minus v1, u2 minus v2, u3 minus v3. Like that, whatever the dimension is, the formula will be the same. Like this you have to write. That means u1 minus v1 I. In the jth direction, u2 minus v2 will be there. And in the kth direction, it is u3 minus v3. This is what the understanding of the addition and subtraction, and even the scalar multiple also I have made you to understand with the scalar multiple of a space of the space vector. Suppose if you want to find out k is equal to, let us say, k times of u bar is there, you simply write this as k times of u1 comma u2 comma u3. That is nothing but ku1 comma ku2 comma ku3. This is what the scalar multiple of a vector. So I have explained you now what is the vector addition, how can you represent the vector addition and vector subtraction on the graph, and how to identify mathematically how to calculate the sum of the two vectors, how to find the difference between the two vectors, and what is the scalar multiple of a vector in a 2-dimension. And when it is a space vector, like in a 3-dimension, if it is given, how to solve it, I have explained you in this lecture. So this is what about the vector algebraic operators in any dimension. You can use the same properties, same addition and subtraction methods are the same. I hope you could understand well. Thank you.